Hey guys, it's our first online course. I missed you guys already, 9A and 9C people. Yeah, I loved you guys so much. So I missed you guys in my classroom. Hopefully this all work out, okay? Hopefully it's clear when I actually teach you guys online. This is my old good notes. I'm gonna take notes with you. And 5.2, I'm going to talk about it. And 5.3, Ms. Tadabay is gonna be talking about it. So we're gonna alternate and give you guys as clear as possible of a lesson. So a reminder, the quiz will be online and it's still gonna be tomorrow, Tuesday. Okay, we're gonna because you have a giant social assessment tomorrow too, so we are actually going to make it due. It's an online quiz and we're going to share with you the link, but it's going to be due on Wednesday. Okay, gonna give you a break from social. So exponent, we're gonna try to identify coefficient, variable, and exponent. So from 9A and 9C, you guys have already learned about what like terms are, but 9B and 9D, you guys might not, and then we're gonna talk about in 5.2, okay? So the exponent, first of all, you guys know what exponents are already. The number of times the number is multiplied by itself, okay? You guys know this already from chapter 3. So 2 to the power of 3 basically means 2 times 2 times 2, 3 times. All right. So the next question, they want you to identify the coefficient, variable, and the exponent. So coefficient is basically if I have a 2x, 2 will be the exponent because 2 is multiplied to this x. And if I have negative 3y, and then negative 3, in this case, will be my exponent to y. Coefficient to y, okay? So in this case, I give you 4 examples here. I want you to fill out the table. What is the coefficient? What's the variable? What's the exponent of each? So the first one here, we have 3w. Coefficient will be a 3 in front of the w. Variable would be our w. And then exponent on the variable, w, is 1. If there's nothing on the variable, it's a 1, okay? Just keep that in mind, please. Hopefully you know that. Now, expression number 2, a squared, the coefficient, there's no number in front of it. There's no number timed by the variable a, so we assume it's a 1. So how about it's a negative? So in this case, it's a negative g. So that means it's the same thing as negative 1 times g. So the coefficient is negative 1, okay? Hopefully you realize that. If there's nothing in front, that's 1. If there's only negative sign in front, that's negative 1. All right? Okay, so what's the variable of this one here? It will be our a. It's not a squared, okay? It's just a, because a squared, the 2 is an exponent. Coefficient for this guy here, what's the number that's actually times x and y? It's the negative 4. So coefficient is negative 4, variable is x and y, and exponent of our variable is 1 for x because there's nothing on there. And then the exponent here would also be 1 because there's nothing on y. All right, so variable, the last case would be g. And the exponent on the variable, since there's nothing here, hopefully you know what's the exponent here. It's hidden, so it's 1. Okay? All right, so I want you to do this chart here, but I want you to pause right now. Do it by yourself. Okay, if you're done, come back to the video. So let's compare answers. Coefficient would be 3 in this case. Variable c, exponent is 2. So coefficient for this one is a negative sign, only 1 in the front. So it's going to be negative 1 times x. So coefficient is negative 1. Variable is x. There's nothing on x as the exponent. So we assume it's a 1. Okay, it's because it's hidden. So there's nothing in front of b here. Coefficient will be automatically a 1, is hidden. Okay, no exponent on b, so the exponent should be 1, hidden as well. Our variable would be b. So coefficient in this case, the number times the variable, so it's 7. Variable is s and t. Exponent is 1 on s and 2 on t. Great job if you got it all right. Next page. Okay, like terms. As I said, 9A and 9C people, you already know. You should know what this means because we talked about it in class, but we're going to say it again, okay? So basically, it's the terms that have the same variables. Two requirements must be met, okay? Two variables, same variables, and the same exponent on the variable. Exponents, only the exponents are on the variable. So basically two requirements here. I'm going to rewrite it here. You have to meet both requirements. Same variable. So x, y, b, a, b, z, y, those kind of stuff. And the second requirement must be met is the same exponent on variable. On variable only, okay? If it's on the number, they're the same. They're not like terms. So examples. These two here, are they like terms? Yes, because they have the same variable x and x. They have the same exponent on the variable, which is both 1, okay? In this case, they're like terms because they are both y, and then they have exponent 2 and exponent 2. This case, xy, yx. Do they have the same number? Oh, sorry, do they have the same variable, x and y? Yes, they just time differently. The order doesn't really matter. It's just the same thing as 1 times 2 equals to 2 times 1, okay? It doesn't really matter. They're the same thing. So exponent on x is 1 and 1. Exponent on y is also 1 and 1. So they are like terms. Do you care about the -5? No, that's the coefficient, okay? The coefficient doesn't really matter. In this case, okay, so in this case, hopefully you can realize that's actually 17 times x to the power of 0. Why x to the power of 0? Because x to the power of 0 is just 1. So 17 times 1 gives you 17. So this one, same thing, it's just the same thing as -8 times x to the power of 0. Okay, so that's also a 1. -8 times 1 gives you -8. Whew, it's like tongue twister. Okay, so in this case, you know that they are the same exponent and the same variable and the same exponent on them. So they are like terms too. So two numbers. So if you see two numbers, just numbers, no variables, they're just like terms naturally. Okay. Okay. Identify the like terms in the group. I want you to pause so we can actually do it together afterwards. Pause now. Okay, if you're done, then let's check answers together. So look for the like terms here. If you skim through these 5 items, you see that you have this and this, which has the same exact variables, b and b, and they have the same exponent on b, which is 1 and 1. So these two are like terms. Okay, is there any other like terms in A? I don't think so. Okay, for B, so you have x and x and x, and these x's, they all have exponent 2 on top, so they are like terms for sure. Okay, so these ones are like terms and these ones are like terms. For C, okay, so you have PQ. Is there any PQ, QPs? Oh, there's a QP. Okay, awesome. Do they have the same exponent? Both 1. So this is 1, 1. This is 1, 1, 2. Okay, so yes, same exponent on the same variable. So any other similar term or like terms? Do you see two numbers here? Like I said before, two numbers automatically like terms. Okay, so these two is a pair of like terms too. Great. So you know, make up 2 like terms for each expression. Be creative. Okay, creative. For 4x, we can say, what if I write x? Do you think is right? It's actually right because x and x, same variable, 1 and 1, same exponent. Okay, I can also write -2x or -x. That works too. All right, 100x, that works too. So this one here, as long as we keep this part the same, okay, it will be like terms. So what should we write? How about just p squared q? Okay, what's the exponent on it, or what's the coefficient on it? The coefficient will be a hidden 1 here, 1 times that, right? Okay, or can I switch the third two letters? Yeah, of course. As long as I keep q with the exponent of 1, p with the exponent of 2. that works too. I just switched the two letters together. And I will write a 2 here just for the sake of it. Okay, so these are like terms. And 8, just come up with 2 random numbers. How about that and that? Yeah, they're like terms. Okay. Now for B, circle the like terms. I want you to pause, do it by yourself, and then come back. Okay, like terms here would be S and S, same variable, same exponent, do like terms. Is there anything else? T and T, they are the same in this case, but this is T2, this is T1, so it doesn't really make sense. So this is ST here, so nothing else is ST, so yeah, that's it. Okay, then combining like terms. This is also something 9A and 9C already know, hopefully. And then if you know this already, just do it together with me, okay? But using a model, though, it's something new for you guys. So we have to actually talk about it. So, okay. Use a model to actually model it. Use algebra tile to show each term. You know how to use algebra tiles already. Some of you really, really love using it. So let's solve this one here. So if you know how to combine like terms already, you might want to combine this to 2x and combine this to -3. But before doing that, let's model it using the squares first, okay? So 4x here, how do you want to represent a positive 4x? Is this one here 4 times? Okay, so am I doing the right thing? Hopefully you realize I'm not doing the right thing. Why? Because it's positive. I have to shade it, which is really annoying. That's okay. Okay, and the -2x. Now, -2x. This term here, how do I represent that? Then I should write down 2 empty rectangles. All right, that's -2x. That's 4x here. That's -2x. And then +3. How do you want to do +3? Just 3 shaded square, small ones. That's +3. And then -6 would be 1, 2, 3, 4, 5, 6. Awesome. There we go. Okay, and then they want you to count. There are how many positive tiles, positive x tiles, positive 4, okay, and then how many -1 tiles? There are 2 -1 tiles, which is like this, and it is here, okay. Write an expression for the remaining tiles. It's basically when we combine these two. If you actually see 2 black ones and 2 white ones, they can cancel each other, so what's left for us will just be 2 shaded rectangles. So basically it means 2x, which is the same saying that 4x minus 2x equals to 2x. Okay, if you actually combine the terms. Why? Because let's say you have 4 apples, you gave out 2, now you have 2 apples left. Okay, easy to understand. We basically, when we're combining terms, we are dealing with their coefficient. We are keeping the variables. Okay, we're just changing the coefficient. We're just dealing with integer operations for coefficients. Okay, so next one. Ugh, I have to do the tiles again. Okay. Label each tile. Okay, starting from the first one. Okay, 2x squared. I need a big box for x squared. Hopefully you know that. Am I doing the right thing? I don't think I'm doing the right thing because I have to shade it because it's 2x squared. It's positive 2x squared. Plus 3x. Plus 3x. So that means I actually don't need the plus sign because the color of the shapes actually represent my signs, okay? So 3x. That's each one of them is 1x, so 3x. Plus 3x, so it's shaded. -1, I like the empty boxes, I don't have to shade it. And plus x squared. X squared should be a big one. Plus x squared. So plus, it should be a shaded big square. Okay, and then minus 4x. Minus 4x should be negative. So that's empty boxes or empty rectangles. That's -4x. or minus 4x, okay? I'm actually going to label each one of them. This is this, and this is 3x. This is minus 1. This is x squared, okay? And then I have minus 2 left. Minus 2, just white little boxes, 2 of them. All right, group like terms to form zero pairs. What can cancel with what? So let's sort out everything. Now black and white can cancel. So you can say I have 3 black rectangles. I have 4 white rectangles. I can cancel 3 of them. 3 of them. What's left over would be 1 negative rectangle. Okay? Is there anything else I can actually combine? Okay. This one altogether, you just count, just by counting, okay? You have 2x squared, 2 large big boxes, and you have another big box here. Can we combine the terms? Yes, we can. 3 big squares. So basically, it's gonna be 3x squares altogether. 3 of them, right? These ones. Okay, and then let's count the this one here. We said this one is the leftover, so that's a negative x. So just write down negative x. And then we have something else left, which is, which color I'm going to use? Oh, this one here. Okay, which I have a negative 1 and negative 2. So we have 3 white small boxes. So that's minus 3 collectively. Okay, so basically that's your result. Yeah, the rest of notes is useless. It's fine as long as you know how to compare the tiles. As long as you know how to combine the tiles or cancel opposite tiles, that'll be the best thing for you guys to do. And let's move on to the next page. Okay. I kind of don't want to draw the tiles, but I'm going to show you how to do it algebraically, okay? So just by using algebra. You know how to draw the tiles already. You know how to combine the tiles, okay? So I'm going to teach you just by looking at the numbers how to do it. Okay, so, and the first thing you do is find like terms. Find like terms, basically. Okay, so the like terms here, 4. Okay, it's a 4 here. I would really suggest you highlight each groups of like term by different colors. Okay, let's do that. Different kind of highlighters, please. 4 and negative 5. Like I said before, if you choose a number or you choose a term here, the sign in front of it actually follows it. So if you actually group up a term, that's the group you're gonna highlight. Okay, including the negative sign. Is there any other number term here? Nope. Okay, I can actually combine these number terms to make it. It's 4 minus 5, right? 4 minus 5, hopefully you guys know, is negative 1. Okay, you should know what that's negative 1. Okay, so and then I have this term here, negative x squared or minus x squared. Is there any x squared terms here? There we go. Okay, so what if we combine those terms here? Negative x, so negative x squared plus 3x squared. Okay, that basically means it's the minus a plus b kind of format. Equals to b minus a, right? This is my little thing I taught in EIA and EIC. Okay, so this is minus 1 plus 3. So it will give you a 2 because it's just 3 minus 1 basically. And 2x squared. It's the same thing as you lost an apple and someone give you 3 apples. Now in the end you basically have 2 apples because you lost 1 or you own other people 1. So, and next one, do I have another like term group here? I do. I have plus 2x and minus 2x. Okay, what's so special about them? Boom, they cancel each other out. Okay, can I just not write anything? Yeah, 0. Okay, you don't actually have to write that 0. I'm just writing it there just for the sake of it. Okay, so combine the terms here. We usually organize our answers by decreasing degree, in the order of decreasing degree. Okay, so these 2 terms here, which one has the highest degree? This one here. So we put 2x squared at the front and minus 1 at the bottom or next to it. That's my final answer. Okay, that's how you combine the terms. Great, if you understand that, then let's move on. So how do we combine terms here? Okay, now let's find out the terms. I actually want you guys to actually do it by yourself. Let's do pause here. Only these three questions. Only these three, okay? Pause, do it by yourself, and then come back to me. Great. So I have a like term here and here. So it's a 4x and a minus 2x. That's my two like terms. I can combine them to 2x with the result of them. Okay, and then I have a plus 3, I have a negative 6 or minus 6. So in the end, the net result of them combining together would be a minus 3. So that's my, basically, that's my answer. Okay, where's my highlighter? I'm gonna use this one. So that's my result here. Answer, done. Okay, next one. I have 2x squared. Like term would be x squared. If you combine them, it gives you 3x squared. Okay, and then I have plus 3x, I have minus 4x, 3 minus 4 gives you negative 1, okay? Negative 1x, do you have to write the 1? Do you have to write the 1? No, okay? Minus x, that's how you do it. I'm gonna write it down in case you're confused. So if these two are combined, it gives you minus 1 times x. I don't write the 1 because 1 just is hidden as a coefficient, okay? So I just jumped to minus x here. Next, like term, minus 1, minus 2. You're making the world darker by losing one hand and by losing another 2 hands. So basically, sorry, this is my example actually used for NIA and IC people. Sorry, I'm being too violent here. But anyway, that's your answer. Next, group like terms. First like term, I'm gonna erase my circle here because it's blocking my 4. Okay, any like term with 4? Oh, that's a number here. Is there anything else? No. Okay, 4 minus 5 gives you minus 1. And another like term group. Minus x squared plus 3 squared. That's like term. Minus 1 is basically minus 1, and this is a plus 3, okay? Minus a plus b equals to b minus a, so it gives you a 2. Okay, that's a positive 2. Why that's a positive 2? Because it's negative 1 is a plus 3, okay? So, yeah, that's integer question. So, plus 2x minus 2x, that's a 0. And you combine everything together. Organize them from highest to lowest term would be this. Can you switch these terms around? Of course you can switch these two terms around, okay? Because its equivalent operation is minus or plus. Okay, these 4 here, definitely pause, do it yourself, come back to me, let's check answers together. Okay. Draw algebra tiles to combine like terms. Oh, do I have to draw the tiles? Oh, okay, let's draw the tiles together. Algebra tiles. So 5x, I have, those are positive 5x, okay? So 5 of them. Oh, I hate my life. Oh, sorry, school announcement. Okay, minus 3x squared minus 3x squared minus 2x would be this minus 2x minus x squared, like that. Okay, then let's count. And how many can we cancel? How many can we combine? These two are the same shape. This one, same shape. This one, same shape. Opposite signs, so we can cancel them up. And these 4, we can actually combine them. Okay, so in the end, I have how many x squared? 1, 2, 3, 4, negative x squared. So negative 4x squared. 1, 2, 3 of the x. Okay, and that's done. This question here, let's combine the like terms. So for k, is there any other k here? K. There we go. So that's coefficient of 1 here. Okay, hopefully you realize 1 minus 3 gives you negative 2. Another like terms, negative 2k squared, another 1. And then that in the end, I have plus 3k squared. because it's minus 2 plus 5, so equals to 5 minus 2, okay? Okay, so plus 3 minus 4 gives you negative 1. Plus 3 minus 4, right? Minus, it's basically 3 minus 4. Can we reorganize, because it kind of bothers me, just like the rules in math that you have to, whenever you write polynomials, you have to organize them from the highest degree to the lowest. Okay, let's rewrite it to organize it up. Can you switch the terms? Of course you can switch the terms around, because it's equivalent operation, like not equivalent operation, but the same level operation, plus or minus. Okay, I want to write this term first. I want to write 3k2 first. I'm omitting the positive because just if nothing is in front, it's just we assume it's positive. Minus 2k minus 1. That's our answer. That's my answer. I'm gonna highlight my answer here too. Okay, hopefully you get it right. Okay, 3.5 now. I'm gonna stop right there. Okay. Okay, guys, for homework, I forgot the homework. Homework. Oh, I hate this thick highlighter here. Alright, I'm gonna write down homework here, okay? It's textbook questions, page 187 to 189. Question 5, 7 to 13, 16, 19 to 21, 25. On my Dropbox, I have lots of practice too, okay? Please make sure you do those practice. If you require the key, if you see any practice question there that doesn't have a key, just text me and then I'll try to make the key for you, okay? So, yeah, have fun.